Over and on the conveyor, there are two main bearings. The bearings are on the shaft ends for the entrance sprocket. They're mounted internally. Each one has a remote grease hose that comes to the surface so the employee does not have to move the grates to grease. Need to pop that on there and grease, and you can see the grease going down the tube, if you can see it in the camera. Okay, until it gets down to the bearing. And then again, this is rotational. It spins 360 degrees, so it's greased once a week. A couple of squirts on either side. There's one here. There's one on the opposite side of the conveyor, which would also get grease. You can stay there. So popping it on here, pumping the same way. And that'll take care of the grease bearings. The take-up assembly is mounted on two steel tubes that ride over a stainless steel shaft with UHMW bushings. Upon installation, the service crew should come in and fill this tube up with grease by pumping it full of grease until it comes out the weep hole here at the bottom. You can see we've got grease already down here now. And this needs to be just checked periodically with yearly maintenance to make sure that that tube has got grease in it. As the spring is compressed and keeps tension on the chain, this whole dolly slides back and forth on this assembly. And by having grease inside here into the bushings, it'll allow it to slide back and forth. The weep hole here is so that as you grease, you don't push the bushings out of the shafts. And that just needs to be inspected on a yearly basis, as well as the bearings. The roller-up air cylinder is mounted here horizontally. We've got air lines coming from our four-way valve up in the back room, forcing air into the unit to push the roller up, and also forcing it down. By forcing it up and down, we eliminate an employee trying to cheat and take a wash by forcing the foot pedal up by hand. It makes it much harder when we put 60 pounds of air forcing it back down again. If you need to run the roller in manual mode for some reason, as an operator, you can turn the air off to that solenoid valve, relieve the pressure, and then the fork will move up and down quite freely. We open up the door here. The foot pedal for the roller up is here. If there's no air pressure on it, it can easily be lifted up, and gravity will lower it down again. When the roller comes up, as we can see here, fully extended in full motion, the fork needs to touch the bottom of the conveyor deck in order to get the roller to lift properly and come up on the top deck. These two guide bars here are what we call our anti-roller jam guide bars. Once a roller sits on top of here, it can't slide left or right, and it can't fall and get cockeyed and come into the conveyor assembly crooked. So it's important to make sure to visually inspect this here on a periodic basis to make sure that the roller up is coming up all the way. If it doesn't, for some reason, it won't lift all the way and stops here, it'll cause the roller to jam straight onto the conveyor. Roller up solenoid valve is a four-way solenoid valve. Again, we got air coming in at 80 PSI to give us our roller up and our roller down. The solenoid valve's got a manual override button here. And as you can hear, we use an air nozzle on the exhaust port side to make it come up real soft and also release soft so we don't get any banging effect. 80 PSI is enough to keep that fork up to get a good roller. If you can see right through the chain to where my finger is pointing here, this is our carriage bolt. This carriage bolt travels with the sprocket and the bearing assembly. And right now, this is an assembly now that is properly tensioned. We can see here that we have about 2 inches of threaded rod showing between the nut and this cross beam. That means the spring that's up here is creating tension and holding tension on this chain, properly tensioned. As the chain wears, that spring will expand, this gap will close, this nut will eventually touch this surface here, and it means that all the slack in the chain will be going to the chain. The spring will no longer be doing its job. And that's when an indication, just by visually looking at it, to know when you need to take a link out of the chain. In order to tension the chain or adjust the tension of the chain, we need to run the conveyor to find our master link section. Just before we run it, we can see here that this is our section, one of our sections with all cotter pinned. And we're gonna have to start the conveyor up and get this section around here to the middle of this unit where we can work on it. So we need to release our safety, start the conveyor, stay here in the trench, and wait till this one comes traveling across the bottom deck again. And we're going to do that now. Like we said, when you look at the carriage bolt and it's tensioned properly, you have about 2 inches between the nut and the crossbeam. And on a weekly basis, when you walk into your tunnel, just look down and glance at that threaded rod. If you see that the nut is now touching that crossbeam, schedule your next maintenance night or your next rainy day to go in there and take a link out of the chain. So you always have proper tension on your chain. To run the chain loose will allow it to wander and find a home and run against the rail or cause excessive wear on the carrier links. So we've run the conveyor around, we've got to our master link section, which is right here. And now we're going to set up for our come along. In order to get our come along to line up properly, we're going to use a heavy duty B belt, B groove belt. Some of the one running our Omni pumps. It also can be done with a chain or a cable. The whole idea of putting the belt in here is to let the come along hang straight. And it doesn't twist the chain. So now our come along is installed. We're hooked into the chain at the front end through the belt on this side here. And you can see now how we're putting slack to the chain here. Okay? So at that point there, now we have enough slack in our chain. Our belt is holding it. For safety, if we come under here, and we take our nut, we run our nut all the way to the end of this plate. Now that nut being held there will keep that chain from ever expanding and have this thing popping apart on us. Even if the come along moves, the chain's nothing's going to spread. It'll now hold the chain in position properly, which ends up freeing up the chain. To remove one link means we need to take out one complete link here, because we have a female section here and a male section here. So to take out a link of chain, we would take out this next piece, remove the pin, same as we did. Okay, take this link out with our come along together, make the connection to tension chain. If we were too tight, we needed to add a piece in, we would add a piece to that chain and then put it back together again. So the procedure moving this one here would be the same. Bend the cotter pins over, knock out the pin, remove this section, then make the connection to the next piece. Slide the chain in, and the end of the pin is slotted. So turn it till it lines up with the hole. Push it right through. Okay. Send the pin back in with your pliers. Bend your cotter pin back. Your chain's been reattached. Now you're ready to release the come along. You need to change the direction of your switch. Releases the handle. The handle goes all the way back to the start position, and this takes a little bit of work, a little bit of pressure, but it's to push it until you get the one click, and the come along will release one notch at a time, automatically putting slack back into the chain. That's 2, 3, 4, 5, 6. Then you can pull this tension back, pull some slack into the cable, remove come along from your belt, remove the belt from the chain, and then at the other end remove the come along from the chain. Release our tension bolt by turning it to the right to run it down the shaft. What we're allowing it to do is allowing the tension to go back into that chain. Chain speed. In order to time out chain speed, what we do is we time a roller travel in 15 seconds. However many inches a roller travels in 15 seconds is the equivalent of cars per hour. So if it travels 5 feet or 60 inches in 15 seconds, and again, that's if it travels 60 inches or 5 feet in 15 seconds. That's the equivalent of 60 cars per hour. At the same 70 inches is 70 cars an hour, and so on. This conveyor here should be running about 60 to 70 cars an hour. The way to test that here is we'll pull a roller up. To measure, we have a start point to start timing our roller, and we have an end point or a couple of marks up there at 60, 70, 80, and 90. The easiest way to do this here is we'll bring a roller up, and as soon as we hit the start point, we'll start our clock, and we'll time this for 15 seconds. 15. So right here, we're running approximately 75 inches, which is the equivalent to a 75 car per hour chain speed. So quite simply, it's a very simple method to use to track that. A lot of the computers have it built into them. If they don't have it and you really want to know what your actual conveyor speed is, this is the easiest way to measure it. Same calculation used by the computer companies. And it talks the same language. Conveyor speed control is adjusted like all the others. This one right now is set just at about 3 1/4, and that was running about 75 cars an hour. If we wanted to speed it up, we would move this towards the 10, and that would get us a much faster chain speed. If we slow it down, we can get a much slower chain speed. So it's infinitely adjustable depending on our volume, our desired speed. That's about 75. That would be probably close to 100. If we wanted to, we'd go to 150. Again, happy spot here is about 75 cars an hour. We'll lock it in place.